Okay, we have a few derivative problems here, a couple of exponential functions and a couple of logarithmic functions. And conveniently, we have our appropriate derivative rules right here. Let's put a little green box around them. Okay, so let's start with A. In A, we are looking for the derivative, of 2 to the x. Oh, it looks like this is a direct application of rule number 1, where a is equal to 2. Okay, so the derivative of 2 to the x should be the natural log of 2 times 2 to the x. Simple as that. Okay, let's get a little bit more interesting. In B, we are looking for the derivative of 2 to the power of 3x. Okay, so we're done with this guy. So in B, this is an application of derivative rule number 2, the derivative of a to the u, where a is equal to 2. And u is a function of x. In this case, u is equal to 3x. Okay, so our derivative of 2 to the power 3x should be ln of 2 times a to the u, which in this case is 2 to the power of 3x, times the derivative of u with respect to x, so the derivative of 3x, which is 3. Now, let's see if we could condense this a little bit. Let's just reorder this product. And let's say this is 2 to the 3x times 3 times the natural log of 2. And we have a logarithm rule that says we could bring this 3 up top as an exponent. So if we're going to condense this as much as possible, I think we could say this is 2 to the power of 3x times the natural log of 8. 2 to the third power, 2 times 2 times 2 is 8. Okay, let's kind of separate these out a little bit. All right, let's look at C. All right, we want the derivative of the log base 10. Now we could drop the 10 because this is the common log. So if you just see the letters log, it implies it's log base 10. So the log of the cosine of x. The log of the cosine of x. So we are applying rule number 4. Rule number 4. So in this case, the a is the base of the logarithm, which is 10. And the u, if u is a function of x, u is cosine of x. Okay, so the derivative of the log of the cosine of x should be 1 over the natural log of a times u. So that's 1 over the natural log of 10 times u, which is cosine of x. And then we multiply that by du dx, the derivative of u, which in this case is the derivative of the cosine function, which is negative sine of x. And we could write this as, let's say, negative 1 over the natural log of 10 times the sine of x over the cosine of x, which is our old friend tangent. Sine over cosine is tangent. So we could say negative tangent of x over the natural log of 10. I think that's about as clean as we could get that one, and that is our derivative. Okay, let's see if we could squeeze it all into one screen. For part D, we're looking for the derivative of, well, actually, before we talk about the derivative, let's see if we could simplify what we're taking the derivative of. So before we start doing any calculus, let's do some algebra. The log base 3 of, I'm going to say x to the 1/2 instead of the square root of x, same thing, x to the 1/2 over x plus 5. Okay, so this is what we are taking the log base 3 of. Now we could apply some log rules to avoid having to use the chain rule and the quotient rule. So let's apply some logarithmic properties to simplify this. Well, the log of a quotient is equal to the difference of the logarithms. So division becomes subtraction. So we could rewrite this as the log base 3 of x to the 1/2 power minus the log base 3 of x plus 5. And we could bring this 1/2 down. So we could say this is the, let's say 1/2 times the log base 3 of x minus the log base 3 of x plus 5. Okay, so now this is what we want to take the derivative of. So take derivative here. Okay, so now we can apply, let's see, we could apply, let's come up here, we can apply both rule number 3 to the first term in the difference, just the log base 3 of x. We could take the derivative of that, and apply rule number 4 to take the derivative of the log base 3 of x plus 5. Okay, so the derivative of 1/2 times the log base 3 of x minus the log base 3 of x plus 5. Well, 1/2 times the derivative of the log base 3 of x. So that should be 1/2 times 1 over x times the natural log of 2. 1 over x times the natural log of 2. Oh, sorry. I meant 3, our log base 3. So 1 over x times the natural log of 3. That makes more sense. Minus. Now we have the log base 3 of x plus 5. So that's 1 over x plus 5 times the natural log of 3. Okay, now we're going to need to scroll down. We need a little bit more room here. Okay, so what can we do? We have 1 over 2x ln of 3 minus 1 over x plus 5 ln of 3. Okay, so it looks like we could get a common denominator here. So we have a 2 on the left, we need a 2 on the right. We have an x on the left, so we need an x on the right, and we have an x plus 5 on the right, so we need an x plus 5, see x plus 5 on the left. Okay, so when we put this together, we have a common denominator of 2x times x plus 5 times the natural log of 3. And on top, let's see, we have an x plus 5 minus a 2x. So we have a positive x and a minus 2x. That gives us a negative x. So we should have 5. We have a positive 5 and a negative x. Okay. I think that is about as compact and as neat as we can make this one. So there's our derivative. We had a little bit of algebra before the derivative, and we had a little bit of algebra after the derivative. Okay, so that about does it for this one. It looks like, yeah, we applied each of the 4 derivative rules while we were going through these 4 problems.